has been working on for the past months since our previous meeting in the spring. And we're going to start with presentation 204, which is our endeavors to update SI and TI for modern video systems. And that's been led by Lucas, Kosman, and Werner.
If I may jump here, and my apologies to my co-chairs here, given a very hard constraint I have around 9, I can probably try to wrap up. Is the standard metadata immediately after, Margaret?
It is, and if you'd rather do that first because of your time constraints.
But I understand that, especially for Werner in Germany, things are getting late. Is it okay, or have people planned around for this specific time slot?
That switch should be fine for me. I don't know how long you're planning to take, but
yeah, I'll try to wrap up earlier. Again, this is an unexpected 9 o'clock conflict that came up. I hope it's okay with everyone else, but I'll try to wrap up as quickly as I can. Is that okay with Lucas and Kosman?
Sure, no problem with me.
I appreciate, and apologies for the reshuffling.
Oh, perfectly understandable. And go ahead, Yanis. So instead, we're going to hear about standard video quality metadata, and we'll hear about SITI next.
Okay. Let me start by sharing here. Can everybody see my screen?
Yes.
Thank you. Yeah, I'll go with a short slide presentation, and at the end, depending on how much time we want to allocate today, or maybe you can carve out some time for later on the actual meat of the work we're doing. So again, this is one of the activities under the norm umbrella. This is a topic that has been discussed in previous meetings, at least 2 previous meetings. It was brought up, and the concept is how can we standardize and encapsulate quality metadata, video quality metadata, in compressed bit streams. So the vision of this project is to make large-scale video quality data available to users, actual users of video, service operators, and researchers at really a massive scale. More than that, to make even full reference metrics that are normally, actually they are not reproducible by having only the bitstream available to the receiver, just they are available at the encoder, to maybe short circuit some of the computationally expensive operations that some of these metrics take. And these pre-calculated scores, again, on the encoder can, when properly combined, offer a very low complexity and hopefully even improved accuracy over the traditional no reference metrics. And in an ideal world, one can see standard quality metadata again as a supplement, where you run some no reference metric and you supplement it with full reference scores that were sent by the encoder, and in some other cases even replace completely no reference metrics that are calculated at the receiver side. The current status, we have a working document, which was the original document tracking the rationale and the various discussions, and another document which was recently started on some now proposed standard methods, right? And I'll elaborate about the T35 for the larger group. And again, these links, this whole presentation will become available, if not already, to all participants. So again, just to give a little bit more motivation, anyone who has run FFmpeg, whether it's X264, X265, libVPX, or other encoders, knows very well that very important statistics, such as average QP, mean SSIM, average PSNR, or VMAF, if you invoke the VMAF library, are available, quote unquote, for free. So they are available per frame, they're available and aggregated further per gap for the whole sequence, etc. And I call it at near zero compute, because really the pixels are so readily available, and these algorithms, most of them are so highly optimized that the additional overhead to compute these numbers is minimal. Problem is that this information appears at some terminal or some console and then disappears. It never finds its way into the compressed bitstream. So once you receive the compressed bitstream, you literally have no way of knowing whether the PSNR was 39.4 or 30.4 or 45.4. You can try to estimate it, but that estimation, of course, takes compute and it's inaccurate. A similar concept is about the raw camera capture, right? A raw camera capture involves some kind of typically video encoder ASIC, and most video encoder, hardware video encoders include such metrics, which again, never find their way out of the chip, even though they are definitely available, if nothing else, for debugging issues. And the thing compounds even more when you consider the typical life cycle of a UGC video, where it could jump and hop from different platforms, right? So it will appear maybe on a phone, then sent over privately through some messenger, WhatsApp, or whatever other application to friends, then posted maybe to Facebook, maybe to Instagram, then further saved and uploaded to YouTube. And each one of these will do its own, let me say, individual processing that ignores what happened before. Again, we have just listened to some presentations on how this can be estimated, but what is best than actually having that information available? So the challenge here is that these transcoding pipelines, which is the dominant source of quality loss, so far, at the best, I can say, are using no reference metrics to determine, again, what is the best ingestion strategy. Jing presented how we can, maybe promote certain videos versus others, or prioritize certain higher quality pipeline versus another. Even during that transcoding step, these full reference metrics are produced, are generated, and sometimes are used to determine best encoding settings. But these estimation errors that we have typically propagate and accumulate, so it finds itself where really you calculate some kind of PSNR or VMA for SSIM, and that's almost useless at some point after a few generation losses. And again, do not underestimate that a lot of the no reference metrics themselves require significant compute overhead. And in the ideal case where you have one source and multiple destinations, imagine if every one of these clients on the receiving side repeats the same operation, which is really a waste. It is much better for the transmitter to do that computation, even if it is a no reference metric, than to be done on the encoding on the receiving side. Okay, so where we are today. I'm happy to announce that VQEG is now an official T.35 terminal provider, which is the terminology used in the ITU-T T.35 recommendation. And here is a reference for those who want to read. But in summary, it is an encapsulation method that provides anyone who wants to offer, let me use the term private data, a means to do so, right? The signaling part contains three. One is the country code. Then there is a terminal provider code, and that's the one that we obtained as VQEG. And then after that, there is a terminal provider oriented code, right? So I'll make it more specific later, but think that VQEG can maintain now its own set of T.35 codes. One is to capture SITI. Another one is to capture, as I've said, quality metadata, and whatever other information we feel is important to be interoperable, even amongst ourselves, and we can standardize it. So in this case, we are under the US. We are registered in the US. We use the ITS, Margaret's work address, as the street address for VQEG, so that you know. And the people listed for formalities only is myself, Margaret, and Sel. So the unique manufacturer code is hex 4810. And now it's up to us to further define those additional terminal provider oriented codes. Okay. The beauty of T35 is that then other standardization bodies, for example, such as JVET, MPEG, or AOM, can then take and encapsulate that entire T.35 message through a very unique, for example, an SCI header, which will simply then add it to the list of other SCI messages. All right. And even more importantly, the exact same messaging, the payload, I should say, can be done at the elementary video stream and the system bitstream without us needing to amend the core definition of the standard except defining these extensions. Okay, so here we are, we have our code. So what's the proposal now after quite a few iterations? So far, 3 different payloads have been proposed, corresponding to, eventually will correspond to 3 distinct terminal provided oriented codes, right? Listed before. The summary payload, please think of it as a one-off that we're gonna carry information about the entire compressed video sequence. More or less what I showed earlier, that is spit by FFmpeg, you know, that spits some summary statistics that says this was a 1080p encoding using, you know, X264. It achieved the global bitrate X and average QP Y, and SSIM, VMAF, PSNR was that. Okay, that's how we should think about the summary. Then the second message, we call it metric instance descriptor, which describes exactly what configuration was, you know, wired to calculate one potential metric value, right? So think the PSNR that I mentioned earlier value. There are, as you know, multiple flavors of PSNR, right? There is PSNR onion Y, where you average linearly or you average geometrically. If you upsampled by a certain amount. So all these details that tell specifically how to reproduce, ideally, that value is in the metric instance descriptor. And finally, the metric instance value is just a value that says from the n descriptors that I want to use to encapsulate quality metadata, the first one has the value 35, and the second one has the value 82. And that would have a one-to-one mapping with how many metric instance descriptors are present in the bitstream. This, again, high level, the proposal. And frequency, right, where and how to place them. The proposal right now is the following. For the summary, 1 per sequence. And by the way, there are 2 sections. One is for VOD, the second one is for live. So the proposal for VOD is 1 summary per file, at the ideally the global, the header in the beginning. The metric instance descriptor would be n. Again, if you want to save n possible quality metrics for that file, you have n descriptors. And then the instance values, the values of the metrics themselves, would be, again, n values per frame if you want to have the highest granularity. And that would be ideal for cases, for example, for researchers who want to, you know, persist that data to allow interoperability with others who will take it and, you know, elaborate it further. Let me say, wherever the overhead that comes by these n values is not really, you know, an issue. Medium granularity would allow just a set of metrics per gap, or whatever that's in the independently decodable coded unit is called. A coarse granularity would say just n values per minute. And finally, there is a possibility to have just a summarized version, right? Which would be exactly the same as for the summary payload, 1 set of values per sequence. All right, that's the proposal for VOD, and this is all up for you know, debate. And the frequency of the payloads, the corresponding payloads for live, is simply to take a live stream that could be, you know, I don't know, 7-10 hours, right, for very long broadcasts, and chunk it into 10 minutes. And for each one of these 10 minutes, consider it a sequence, right, where you apply those frequencies that were listed previously for, you know, for these 10-minute chunks. Okay. All right. Any question on this high level? Okay. So hearing none, again, the detailed proposal is the link that I would like to follow to walk through what is currently being tabulated. And I would like some guidance from the group whether we want to dive deep right now and get it ironed out, or at least have a draft. Before I go to the detailed proposal, I want to say what are, in my opinion, are the next steps, and I propose here.
Yanis,
We should
sorry,
have
there are 2 questions here.
Yeah.
Sorry, yeah. One is from me, and I'm just wondering. So you mentioned this like lifetime of the video when it gets from one platform to another and so on. And I'm just wondering, if we calculate the metrics at the beginning, isn't it possible that these values change throughout this lifetime, because some platform can add some distortion that is no longer captured there? Is it possible to then update this, or how this is going to be captured?
Yeah. So again, the idea for live is to update, if you like, every 10 minutes, the summary. Of course, the per frame one, obviously, is what it is, right? You don't really need to do anything. You just calculate and save, you know, the every frame's VMAF, if you like to do so. But when it comes to the summary, you can decide how often you want to summarize. But in an ideal scenario, you have a live encoder. The live encoder produces metrics per frame. They are accumulated here, as I say, every 10 minutes, and then put, obviously in that case, you know, the first frame of the 10 minutes is already gone, right? The placement of the summary will not be in the beginning, but would be in the end of those 10 minutes, obviously, right? So
yeah, this I understand. I was more considering the VOD case kind of scenario where you've got a video that is fixed, but then it travels from platform to platform, and there might be some additional distortions. So I'm not sure if there's any updating there.
Yeah, so let me again be clear, and I should have probably clarified it. We should all imagine that this is information done by the encoder without really knowing what will happen during transmission, right? So transmission impairments are only visible to the receiver, but not on the encoder side in general. As a result, if a decoder now, upon receiving what the encoder submits, where the quality is done during encoding, can run a no reference metric right upon receipt and update and say, hey, my version now actually is not what the encoder sent, but it is updated. It is up to the decoder to, again, create a new bit stream for local storage and further redistribution, where the transmission impairments are also encapsulated. And I'll get into that detail when I talk about generations and the concept of generations, right? So the first generation would be what the encoder produced. Set of PSNRs, VMAFs, SSIMs, and that's it. It goes into the file. Then that starts getting transmitted, and during transmission, stalls or other impairments happen. The receiver will receive what the encoder claimed was the quality that was sent, but that doesn't mean that that's the quality that it was received, which means that the receiver now has the full freedom to recalculate its own version of perhaps no reference metric that takes into account what the encoder claimed the quality was during, that was transmitted, and modify and say, my version, in other words, my compressed bitstream, the one I received, has a second generation of, impairments. And that second generation of impairments results into this aggregate or incremental quality loss. Does this answer the question?
Yeah. So, and it also means that if there is some or transcoding happening, you're creating a new stream, and that means a new set of metadata as well, right?
And you said that ideally is appended, and that's one of the key elements here. So you as a transcoder, you may decide, I'm honoring the PSNR, VMAF, SSMs, and whatever metrics was done from my first, either my capture or my first transcoding. And I'm simply adding and say, so that that quality has further been degraded because I transcoded using a new set of parameters. And then I know it was a VMAF of 95 from the first, and then now it's a VMAF of 98 from my second transcoder. But guess what? If I'm now the recipient of that second transcoding, I know both the 95 and the 97. So I know that with the ideal pristine source, if I were to estimate what is my quality right now, I would probably take some kind of minimum of the two or something below that, if you like me to say. Again, how to fuse the different transcoding steps to come up with a global equivalent of a no reference metric estimation is up to us and other researchers to do. We simply talk about how to encapsulate that entire chain of transcoding events in an efficient way, in a way that is consistent, right? So if I have both of these transcoding steps, individual qualities, then I have the freedom to do further data fusion or other methods to estimate what is the received quality. Any other questions?
Okay, thank you very much.
I heard that there was a second question, but unfortunately, because I'm sharing, I don't see the queue. So Margaret, if there is nobody else, I'll continue. Okay.
Sorry. Hold on a second. I see one hand. Baloo? Sorry, I was writing in notes.
For some odd reason, I thought Lucas was before me, unless Lucas decided to drop his hand.
Lucas already asked the question, Balu.
Okay, sorry. I can't see any visuals here. Anyway, this is really helpful, Yanis. Thanks so much for putting this together. I'm also wondering, going back to like one of Margaret's presentation about having some notion of creator intent and other stuff as part of this no reference metric. I know that this is probably a little bit out of scope of this work, but like, is there provision for adding more to the payload other than just quality metrics, like, indicators that are helpful to detect a little bit more, and also used as tools for the creator to say, this is creator intent, or this is like more important, even though the quality is less, it is more helpful for the narration of the video or whatnot, right? So that sort of indicators, if they're part of this payload, that will be even more helpful, both from the creator perspective as well as from the transcoder perspective.
Excellent point. And the short answer is yes. The provision is for the standard to be open, in the sense anyone can come into VQEG and say, I'm proposing this, I'll call it for now metric, but it can be a feature, right, or an indicator, which needs to be, although clearly defined, and we'll talk about this, the way to define it. They will get an enumerator that says that's going to be enumerator number 25, for example, right, called creativity, called blurriness. Or again, it's totally open. So the idea is that we should not restrict it to this, to the very strict definition of a metric, right, where you have either full or no reference. It can be anything that we find be useful, and it's going to be supported and maintained by a registration authority where people can either submit their no reference metric, their features. Those 11 features that were mentioned by Margaret are very good candidates. For example, whatever values come up from, ideally, again, standardized networks, right? Networks that are clearly defined and reproduced. There is a little bit of a debate whether closed source values, right? If I say I have my magic box and my magic box says this is 25, I'm not sure how much value this brings to the industry. But again, we may be open to some, I can say good, magic boxes. Of course, in my opinion, should include already standardized methods by ITUT, and that includes, PVQ and Margaret, I forget the method that was standardized as part of HT. So in other words, we should be all inclusive. This is my number one suggestion here. Does this answer the question, Balu?
Yes, it does. Thank you.
Okay. So again, the whole idea is to have at least a way to communicate with each other with information that is ideally put in the bitstream. So you don't need to send someone and say, by the way, I used X264 medium 3 megabits per second, whatever AQ mode. So we have at least a repository and a dictionary we can use amongst ourselves to capture that in a standard way. This is the ambition of this project.
Awesome. Yeah.
Not restricting by any means what goes in and what stays out.
Yeah.
Okay. Anything else? Otherwise, I'm moving ahead. Okay. So this is the detailed proposal, and these are the steps, right? So I think that it's a good plan to have at least a working draft that we, amongst ourselves, a draft, not finalized, we sort of agree, right? We haven't missed something big. And then it's quite important, this was flagged by a number of people, most namely Alexis Trapis, who expressed a great interest, because we do need to understand that other organizations, in particular in this case JVET, have been circulating proposals of similar nature, even though I think I presented the one during the last VQEG meeting, they are fairly restrictive when it comes to what is included and what is excluded. They are very, very narrowly focused on, say, only standardization and the fact that you want to store PSNR and SSIM, for example. I think that does a disservice, in my opinion. So the sooner we have that working draft circulated and collect opinions from, I'm listing the two major ones, but others that people can think of are more than welcome. Then we can collect that feedback, incorporate it, and finally get to something that we can post. And again, remember, we don't need to post and involve other standardization organizations at this point. We can simply say we have this public portal where people can look up and say message number 0 means PSNR and it is defined this way, right? Message number 1, or sorry, metric number 1 means SSIM and it means that thing. And message number 25 is blockiness, and message number 26 is creative intent. And again, there are clear references that persist. And so people who, they don't need to, to scratch their head on how things were done. Okay, these are my proposed next steps. So are we ready to dive into the proposal? And my question to Margaret and the group, how much time we have and what can we accomplish in the time frame we have?
We have quite a bit of other content to go over today. Would it be okay to have this discussion Friday session 2?
Yes, absolutely. And for me, it fits very nicely with the conflict that I disclosed earlier. So allow me then to simply click on it so people can see its existence and acknowledge the great help from Werner to really beautify and tabulate in a really nice way. And I'm really, I just want to show what is a very, very high level section without really debating. Is that okay? I take silence as an approval. So I'm clicking, hopefully my links work here. Or maybe they don't. Okay, something happened. And one of these, yeah, okay. So can people still see my browser?
Yes.
Yeah.
Okay, so these are the proposed messages. And I'll start a little bit from the bottom up. And again, it may look a little bit out of order, but I think these 3 tables are the ones that are most critical for us to sort of slowly build, right? And the nice thing about it is that these tables don't need to be agreed. All it takes is for a proponent, I call here proponent, and I already volunteered my name, to say, okay, I'm grabbing the first entry, I call it PSNR, and I'm actually defining very, very specifically in a standalone document how this is calculated, right? So what is needed, let me say, on the infrastructure side, is to have now a web page dedicated only to this purpose, right? Where we can say this is where I can clearly see that the metric index 0 means PSNR. So wherever I'm invoking in my message 0, people know exactly what it is all about. Okay, that's one table. Let's call it the table of metrics or features, as it was argued before. And it doesn't need to be constrained. It can be, again, SI, TI, creative intent, as long as it's something measurable that can be associated with some kind of value. And measurable, by the way, can be a binary flag, present or not present, right? For example, field grain, yes, no. If you have an amount, for example. The second one is the interpolation method, and we will explain, but very high level, remember that it is by now, I think, a very common practice to accept that the exact same video, compressed video, can be decoded and compared against different flavors of the original, right? We call it sometimes different viewport quality metrics or different resolution quality metrics. So it is inherent and very important to identify how that either downsampled or upsampled version was done, right? So to capture these interpolation methods and explain them so that people know exactly what they're talking about. So we can say that, for example, this PSNR value was calculated after the decoded, bitstream was upsampled to a 1080p source by using a Lanczos filter with alpha 5. That's very valuable information that should find its way into the bitstream, right? So again, a list of interpolation methods is very important to be maintained in a very similar way that we maintain metrics. And finally, how things were temporally aggregated, right? So we all know very well that, for example, for the summary metrics, how did you aggregate? Did you aggregate by simple arithmetic mean? Did you do harmonic mean? Did you take the median? Did you take pooling of 60%, 80%, or whatever other aggregation methods need to find its way for, again, unique identifier, right? So these are, in my opinion, the 3 registries we need to maintain. And of course, I'll be very happy to expand it if we see there is a need for an additional registry. Now, how are they used? And again, let's go through very high level what the summary payload looks like. Okay. Some kind of versions which will allow us in the future to revise, right, and say now okay, version 1, 2, etc. Now the generation index is extremely important. It really tells you from a series of transcoding steps, which is the first, the second, the third, the fourth, right? So at least in this way, you can now have multiple metadata using, I can say metric values, using exactly the same metric, but it's going to be the VMAF value of the first step, or the VMAF value of the second step, or the VMAF value of the third step, as an example. Which video codec was used for that, for the corresponding, generation. If there are some information specific to the codec, such as profile level, if it is present, what are these? What were the color primaries, bit depth, and important that is very fundamental. And again, please keep in mind that none of this survives today, right? So the moment you receive a 540p UGC upload of a great show that was originally available at 4K, HDR, you have completely lost that background, right? So at least in this way, people can see what was the original source, right? Whether the original source had, for example, as I've said, film grain and such. The frame resolution of your origin of that corresponding generation. How many? How long was the sequence, right? How many megabytes or bits? How many frames? How many iframes, p frames, b frames? Again, average stuff, right? Average quantization parameter for I, p, b frames. And now here, the metric instance values should be, yeah, and Werner is indeed correct. We should first list what are the metric instance elements, right? We are including, in other words, VMAF, SSIM, and PSNR, and what are the corresponding values, right? So now for the metric instance descriptor, which, as you understand, it is involved also in the summary. Here you need to specify what is the generation index, the type, and this is where the table I mentioned before comes into play. If for some of these, for example, there can be 10 flavors of PSNR differentiated by whether you do Y or CB, CR, a weighted of the three, you can have a configuration parameter or sub-option. The reference resolution, again, if it was, in other words, a 540p, but the reference was 1080p, you indicate that I compared with the 1080p source. And I used that interpolation method, and here is the second table. And by the way, if I aggregated more than one frame, I used this temporal aggregation method. The additional element here is that these metrics could have been calculated on a sub part of the frame, where you indicate which region of interest was used. And that, we hope, captures as much as you want to convey about how one of these metric values was calculated. And these are some examples of making it a little bit more concrete, or at least trying to make it more concrete. And finally, the value itself, which is extremely thin, hopefully. Just which generation index, which metric instance. So you can think of it, first generation, metric number 0, which means at the original source, PSNR, had the value of 38.4. Okay, that's it. Nothing else. A great debate happened. Yes.
Yanis, we have a question from Lucian.
Yes, please, Lucian.
I'm not sure if this is a valid question, but will you have a place for, like, I'm not sure how it's calculated? Like, let's say I write a code to send the data from a camera. I do not have access to the camera. I cannot, I see that the camera is outputting something that is called PSNR, but then I cannot really name exact implementation of the PSNR.
And that's a very valid point. We can have unknown or unavailable as one of the options in all of these, either region of interest or temporal aggregation or reference resolution. We could have not present or unavailable. And a great great feedback.
But to some extent, it's like I guess there is a PSNR. It is PSNR because this is named like that. But I cannot guarantee that this is exact implementation. Yeah.
Sure.
So
Again,
then, like the aggregation of the names, like the general PSNR comparing to PSNR X, which we exactly know.
Yeah. Again, the method configuration, right, says that I know how PSNR was wired. I know it was only Y, and it included, this formula. Or it's here. You can, when you define PSNR, you can put a value that says that value means I don't know exactly how PSNR was defined. That would be the right place when you describe whatever metric you are going to put later on that I really don't know, right? So every metric has its own sub configuration, and one of these sub configurations could and should be unknown. Does this make sense? And similar thing for the aggregation method, could be unknown as well, right? Okay, so after that, the one thing I want to highlight, and I think that's the last point I want to make, is that when it comes to temporal references, right, the most natural way to resolve where the specific value, which frame does it relate to, is to make sure that for frames, it is really appearing in the bit stream exactly at the end of the last frame that it captures, right? So in other words, if it's one frame, the corresponding T35 message that carries the value is immediately after that frame. So you know exactly which frame it refers to. If it refers to a gap, it is at the end of the last frame of that gap where it refers to. So it's, let me say, the actual location of the message itself is indicative of what is the corresponding frame that it refers to. There is no, in other words, other explicit index here, if you notice in the metric value, that says which frame this maps to. Otherwise, I think it's going to become extremely difficult how you number your frames, frame reordering, frames lost, and whatever else. And with that said, again, we will dive deep into this document. So please take the time, like Werner did, to give feedback, because if we get to a point where we have a draft, that will unblock us from sharing it externally and getting more feedback from the organizations that are most likely to adopt this, or allow it, I should say. And at the same time, Margaret, I know the burden is a little bit too high. We need to talk about a website that is consistent and maintains these 3 tables, even if they are mock-up tables right now, placeholders, if you like to be called. I think we should have some basic design where one can find in a single place all the T35 related messages maintained by VQEG. Thank you.
I completely agree. Maybe let's put that as an agenda item for our next NORM audio call.
And again, thank you all. That's what I had. I'm personally very thankful to the contributors every 4 weeks who diligently devoted the hour or so to reach to the point where we are today. I don't think we would have reached without this very important help. And I would really like to call out Werner's contribution, both to make this document more readable and his valuable contribution along the rest of the NORM community.
Okay, thank you. Thank you, Yanis. At this point, I would like to move on to presentation 204, the updating SI and TI. Lucas?
Yes. No, so this is something that I'm going to share. Yeah. So yeah, thanks, Ioannis, for presenting this high-level overview. I think there's a lot to explore. I think people really should take the time to read through this. I think it would be very useful to get this published soon. So I'm just trying to find my screen. Yeah, this is a hopefully short presentation on our updates to SI and TI that we've been doing over the last few months. This was done together with Lukas and Cosmin's help. There's been input from several other people. I'm just highlighting them because there have been a lot of contributions to the code and feedback on the design of the tools. So what are we doing? Well, we're looking at SI and TI as they are defined in ITU Rec P910, and they have been there since, I don't know, or they've been there for 20 years or more. and they haven't been updated since. And we know that they don't work very well for different types of applications. Also, there have been problems in getting them, different implementations, harmonized so that they actually calculate what has been intended. So although it seems simple, this has led to some problems in the past. SI is basically just a Sobel filter applied on the image, and you calculate the standard deviation on that. And TI is a basic motion difference feature for adjacent frames. We've seen that we have had problems with different implementations. So one of our goals was to harmonize existing implementations with respect to handling of the edges of the picture, also dealing with input that has limited or full range of pixel values, which hasn't been properly handled so far. And to solve that problem, we've published an implementation in Python that has been verified by multiple people and that has been cross-verified against other implementations. And so we know that it works correctly and as intended for standard 8-bit content with limited and full range. Now, things get more difficult once you get to more than 8 bits per channel. And this is where we're thinking about how to properly map the pixel values to a common scale to still be able to use the SI function as is to get an estimation of the spatial activity in the picture. And another big topic was handling HDR, because there you couldn't just compare the encoded values as is, because they mean different things depending on which type of HDR content you're looking at. And so with all these aspects, we're trying to provide an update for the recommendation so that SI and TI become more future-proof. And on top of that, this is a bigger goal. We want to create an even better encoding complexity metric. There's been a proposal by Ioannis to basically enhance SI-TI with a motion compensation feature based on an algorithm or an actual implementation that he's been working on for quite some time, that he's iterated over in the last few years. And he said he would be able to make this code available for us so we could integrate it into that pipeline and use another feature, which is basically motion compensation. There are multiple features related to motion in the picture, and we could use that in addition to SI and TI to get an idea of how complex a source really is. So what have we done so far? We have a new software developed, which is written in Python. And so here's the big caveat. It's slow, but it's at least a good experimental platform. This can definitely be optimized. And it's important to note that we have two branches. One is the stable main branch, which is the good old, which I will call legacy SI-TI. And you can use this to compare other implementations against. And then there's another branch called SI-TI 2020, which contains all the updates we've done so far, and it's super experimental, and it might break from time to time, but this is where we contribute the code. We also sent a liaison statement to ITUT Study Group 12, which is responsible for P910. We've informed them of our activities. We told people to join our monthly calls and make contributions if possible. And they were welcoming these changes, and basically we should just send a proposal once we're ready with it. So the software itself has a command line interface, but it also has an API that you can use, so you can directly call the functions as needed. It's important that we give the user options to select the bit depth and the HDR mode and certain functions for converting SDR to HDR, for converting HDR to a common scale. And I will go into details on this later. And to also change the parameters for this, because we're not actually sure what our final goal is here. We don't have a ground truth to match. So people might have different applications. So they want to choose different parameters. And we wanted to give them the possibility to do so. For now, we can read Y4M containers. We can also read other containers, but we want to focus on Y4M because it's a very simple format for uncompressed video. It's kind of interoperable. It's not really standardized, but there's basically the implementation in FFmpeg that is the de facto standard. It has a bit of problems with content that is uses more than 8 bits per channel. It doesn't have signaling for HDR, so this is not ideal, but we have to live with this. We will have to look into how to properly read and interpret HDR content based on whatever is signaled in a container. But we would assume that people who are really designing codecs or anything around video encoding are at least knowledgeable enough to feed content into the tool and get it to output some value that is meaningful to them. So we then read frames from the container and we convert them. And there's a pipeline that was initially proposed by Lukas, and we've iterated that several times. And I'm going to show you that later. Maybe Lukas wants to add a few notes here, because I'm really not so much of an expert here. But yeah, we'll get to that. And once we have the frames, we calculate SI and TI with the good old functions, but now in a different domain. So it's not the encoded pixel values, but it's a perceptual domain. And based on these outputs, we can generate JSON and CSV files. So now it's time for a quick demo. I need to share another screen. Give me a second. So I have the repository open, and I can run a simple Python command on a classic that some of you might know, which is the 4-man video, and it has a few frames. I think it's 10 or so. And the tool will output a JSON object containing SI and TI values per frame. You should note that the TI array has one fewer value than SI because there's no TI for the first frame. This is another problem that some implementations have had. So we're just leaving it out here. The tool also outputs an object with the used settings, and we thought this would be useful because sometimes, the problem with research is you generate some outputs, you dump them into a file, and then you might need them years later, and you don't know how they were generated. So this contains all the settings that were used, including the version of the tool, so you can then go ahead and reproduce the same values basically automatically. So the tool can use its own output as input to run the same calculation again. We thought that would be quite useful. You can also debug the output, and this is what we're using now actually quite a lot. You can see the histogram of the frame data. This is useful because we're actually changing the domain of the values. So you can see that the luminance values change in their distribution, and this is what causes the new SI to be different from the old SI. And we're now looking into what that actually means for the output and whether that better reflects encoding complexity. So going back to the presentation, just have to find it. There we go. This is the pipeline. It looks quite complex, but bear with me. So we extract luminance from the input. We have a special wrapper for FFmpeg to do this in Python, and there have been quite a few problems getting the real values out of a container because FFmpeg tries to be clever and apply a grayscale conversion to the output, and this is not what we want. At least I think so. This is just a pure Y component. And then we normalize it between 0 and 1. So this means that no matter what your input bit depth is, you get values between 0 and 1 because we don't really care if it's 8 or 10 bits. so we can easier work with this on an easier scale. Now, we can also scale limited range values to full range. So basically, if your input is limited to 16 to 35, we stretch that to become values between 0 and 1. And then we have a normalized luminance value array that we can use for SI calculation. And now it depends on whether we actually use HDR or not, and if we do, which HDR mode we're using. So if we were using HDR10, our values would already be in a perceptual domain, so we wouldn't have to do any further processing. If we were using HLG, we would apply a display model to get the values into the physical domain. And if we were using SDR, we would use a different transfer function, which is a good old gamma function. And then we would have values that are in physical domain, in display luminance. And now we can use an inverse function to get values in perceptual domain, in the PQ domain. And on this domain, we calculate SI with the function that is the good old function, so we don't change anything here. And then to accommodate for differences between different input bit depths, we scale it back up to the old 8-bit range. So that means even if you used different input bit depths, you would still get SI values in the same range, because otherwise they would, of course, also differ. And that should hopefully make 8 and 10-bit content also more comparable. Now, I've had problems accessing some HDR test files, so all I have for now are some results on standard 8-bit SDR files. I used an open source database with a few known contents, and those are just 10 seconds 4K contents with 8-bit SDR. And here we're just comparing the legacy SI and the new one. And you can see that in general, it's doing the same thing, but the values are a bit lower. And that is, as Lucas mentioned, due to, well, the perceptual domain kind of giving more weight, I guess, to other values. I would have to look at the histograms in more detail and see why that is. Maybe look at the images that are generated. But yeah, this at least means that the functions do what they should do. So this is not hugely changing, but it will be interesting to look at what the perceptual effects are of that. And especially what happens when we compare different bit depths, and once we bring HDR into the picture, I mean HDR of the same content, but this we will have to still explore. And then I ask myself, like, is this just the same? Does it have 100% correlation with the input? And it turns out it doesn't. So when you normalize the SI-TI scores per group, meaning that the old SI and the new SI have the same center and the same range, so you z-normalize it, and then you plot the correlation. If they were the same values, just shifted, you would expect them to be on a straight line, but they aren't. So that means there is a bit of a shift in terms of how SI is being calculated. So things are weighted differently. So we do see some differences, but at this point, I'm not sure what they are, like what this means for encoding complexity. But at least we now have the tools to look into that further. So where are we going now? We still have a few performance issues to fix. This is really slow. We should probably use fixed point calculations. We should probably use native C extensions to be faster. We can do parallel computation. We can do threading with queues. This, I guess, I will implement in the next few weeks. Then we have the issue with the range. So now you saw that the values are not perfectly comparable. Maybe we can find a way to fix this, but maybe it doesn't matter. I would appreciate your thoughts here. And then we have an open issue with an alternative transform that we wanted to try that I actually fixed in the meantime, and this shouldn't even be here. So there is a list of issues on GitHub. Everything is documented. We have the meeting notes that I think I should add here, but you can find it on the VQEG website. And yeah, that wraps up the presentation. So let's open the floor for some questions, or maybe Cosmin or Lucas, maybe want to add something first. Thank you.
Yeah, thanks so much, Werner, for presenting. And I just wanted to add a little bit. If you could bring back the slide, just
sure.
The slide 7, just a quick clarification and potentially an explanation for the reason why we are actually getting lower values. So in this, why it's really important is these two EOTF functions, especially for HLG and SDR. And these actually come together with a display model. So not only we are using a function to bring the values or to transform the values into a perceptual domain, but then we scale them differently according to which mode we actually use. Because so for the SDR, we are considering something as like a standard SDR display, which has maximum luminance of 300 nits and the minimum luminance of, I think, 0.1. And for HLG, we are considering 1000 nits and 0.01. So this is what actually determines the range of values we can get in a PQ domain. And if you think about the way old SI was calculated, since it was calculated in the regular Luma domain, you could spend all the values from 0 to 1 or from 0 to 255 in terms of 8-bit. Whilst if we consider this model, in SDR, we are sort of limited to the values from 0 to something like 0.629 or something like that, which is an artifact of us trying to put SDR together with HDR. So that's what I imagine is bringing down the values, but also inherently it will bring them, like make them more comparable to the values that we can get from HDR. So I personally don't really see this as so much of an issue if we just accept that the new SI-TI values are in the new domain, in a perceptual domain, and they are common for any type of content. But obviously, this is up to debate, and there are other ways we could try to mitigate this. There could potentially be a change in the display model. So instead of using 300 nits, we can increase that and bring the values higher up and see, or maybe even see if this actually does bring the values up. So that could be something we can try and just to play around with. And yeah, just to explain the PU transform, there is a different, more perceptual domain. So we are playing with exchanging the PQ that is used to calculate SI with even more perceptual domain. And that one would actually include also the EOTF used on the PQ. So that's just an addition to what Werner was presenting. Thank you.
If I may ask very quick, I know I'm jumping the queue, Nabajit was ahead of me, but Lucas, I somehow thought if you go to lower, like 100 nits, the values would be higher. I guess I got the direction wrong here. You're saying if we switch from 300 to 100, we would get higher or lower values? What's your...
I think we would go lower values, because then we would be calculating SI-TI on the range from 0 to something like 0.5. So this is an artifact of how the SI function actually works, because you are taking, I think it's just a gradient, right? So if you have like compressed dynamic range of the values, you will get smaller values as an output.
Anyways, yeah.
So,
I have another question, but I want to leave it back to Werner to get the discussion.
No, maybe I can just I just ran the code, and so with the 300 nits, I get higher values than when I run it with 100 nits. So
yeah, so that's what I expect. And if you would run it with 500 nits, you would have even higher values.
Yes.
The proof is in the pudding, right?
Yeah.
Okay. So I guess maybe Cosme first as a contributor and a co-chair of this activity.
Do I have my hand up? I didn't think so.
No, you don't.
No,
you
you
were just
don't.
given the opportunity to say something.
Yeah, if you wanted to. Otherwise, I'll jump. In the last 5 minutes, I at least I
No,
have
go ahead.
Yeah, I just want to, first of all, so I just want to, first of all, thank Werner and the whole group of people who have worked diligently. Just an update, as Werner said, we have finally achieved the point of, we have again, this is the alternative, which is the motion compensated, or at least try to more accurately track coding complexity. In very high level, it is similar to the presentation we just heard about capturing, again, things that are more codec related. We finally achieved the necessary agreements to have the code open sourced, and we are actively working to make it, as I say, more presentable. The current version is running only on Windows and Visual Studio, so that's our number one effort, to make it cross-compiled so people can put their hands on, and then hopefully put it to the test for others to contribute, fix, and eventually perhaps even adapt. But that's just an update from my side. We're happy to say we're getting there. I don't know what they will send, but there will be an email going out to the Reflector announcing what GitHub location and how we can collaborate.
Oh, thank you. Sounds good.
Thank you.
So,
I think Nazi next.
Thank you, Margaret, and thank you, Werner and Lucas. I just have a quick question regarding the processing chain that you showed. Can you just reshare it if you don't mind?
Sure, no problem.
So in this one, why do you normalize before the other steps? Is there a particular reason behind that?
So you mean the first normalization depending on bit depth here?
Yeah.
Yeah, it's just that so you can compare 8 and 10 and even more bits contents more easily, because otherwise you would get a completely different range of inputs for the ESI function. And so the magnitude of the outputs at the end of the calculations would be quite different, right?
Yeah, basically you want to use the same functions for no matter what bit depth of the initial video was. So this just brings it to the same range for anything, and then you can use the same set of calculations for both 10-bit and 8-bit content.
Okay.
So there would have been the possibility to do everything on the original input as is, I suppose. But anyway, you would have already had to normalize when applying the transfer functions, right? So there's no point really, I think.
Yeah, that's correct. And also you would have to signal all the time which the initial bit depth was, so you carry the information whilst you don't actually need it if you do the normalization early on.
Okay. I think I get it. Thank you very much.
Shahid?
Thank you, Margaret. So I have a comment on this adjustment of the values. So I think one argument that goes into bringing the values on the same range as the one before is that people have been using SI&TI for some time now. So to make it, let's say, compatible with the previous computation, it makes sense to actually bring it on the same range. I mean, one can of course argue that what is the accurate range, because as you mentioned that there were many different implementations, so there is no correct let's say reference range to map it to. But if we take all these implementations as kind of a wide Gaussian noise, let's say, on the values, then still there is a kind of a mean value we can actually map to. So I think we should not create another set of values which are different from the SI&TI computed previously.
Yeah, I think there's a valid point here, but indeed, I mean, even looking at my own computations of some data sets, I saw that they were like widely different. And so, but in principle, if we had a large enough corpus of representative video, we could just, add a constant in the end to bring it to somehow the same average, if that's what we meant by the distribution. But that requires us to have a good test set that is kind of representative of what people will be using. And maybe it's not such a big of a problem because anyway, usually this is done with a closed set of sources where you're comparing within a test one source against another, and it's not something where you compare different sets of sources that you don't have available in front of you, where you could just run the tool on everything at once, right?
Mm-hmm. And I actually have another question. It's regarding the thing that Yanis mentioned. This motion compensated SI&TI, is it being discussed right now, or it will be brought up again sometime later?
Yeah, so it's a bit unfortunate that Yanis is dropping out now, but there have been. So I think we took quite some extended meeting notes, so maybe you just want to read up on those if you're interested. So the short summary is that Yanis has code available that is basically a very basic motion compensation algorithm that can mimic the motion compensation that different encoders could do with different block sizes, etc. Frame GOP types, and we will be trying to implement this into the pipeline. So we have to look at the code, see whether we can make it run on different platforms, maybe create a binding for Python to call it, and provide this as an additional feature for the output. And then based on a set of test videos, see how that relates to TI, how that relates to actual file sizes when encoded. And here I think the main discussion point was, what should we focus on? Should we focus on a very generic basic motion compensation algorithm that assumes a generic encoder, or do we want to tune it for certain existing encoders or macro block types, etc., which would, if you drive that too far, I guess kind of defeat the purpose of doing this exercise at all, because then you could just encode the video and see what the output is. But that is the basic idea. And so the next step would be to have the code available and see how we can integrate it.
That was actually my comment, that I mean, whatever we will be doing will be mimicking a codec. So why not actually use the codec in two different configuration? One can be the intra-only configuration where outcoming result will be something like SI, and one can be the I infinite P configuration where the outcoming result will be something like TI. So I was a bit confused actually why we are pushing for mimicking the codec using a simple motion compensation or interpretation, etc.
Yeah, I don't see if anybody else has the hand raised because I'm just sharing the screen. Just my comment would be that yes, I think that is the underlying question to all of this. But I think people want something generic, something that could maybe last another 20 years or so, that doesn't rely too much on specific optimizations and implementations within certain codecs. But yeah.
And to answer your other question, yes, we have 3 people in queue: Lucian, then Cosmin, then Lucas. So, Lucian?
Thank you very much for this work and presentation. I'm wondering because one of the reasons we have it is to have a stable implementation that is very solid. So how much stable are those transforms? Like, we are sure there is one implementation of this transform function that is, changing the bits, or is something that could be changed in the future by the new recommendation, somehow we are kind of certain that those transforms will stay as they are.
Lucas, you want to take that?
Yeah, I can take this one. So these are all standardized, and for example, the PQ transform is meant to be really future-proof, and it's part of the way, or it's deeply embedded in the way HDR is processed at the moment, HDR video, I mean. So there is virtually no, well, I don't see a way of this changing, and if so, SITI would be the least of the problems. So I think these are fine. The only issue that I would see would be this this display modeling, because with development of, for example, SDR display, we may reconsider this in the future. However, I think that we are really good with capturing all these things with this JSON blob that actually gives you all the information how these were calculated. So you will always be sort of backwards compatible anyway. So all the things that are changeable should be captured in the JSON file, and the things that are not, we are just planning to keep them, not touch them. And if by any miracle this would change, we can always implement another version of it and then rename it, and then always have it in the JSON file as version 2 of BU21 or something like that.
Thank you very much.
I believe Cosmin is next.
Hey, so I was going to address the earlier question about the SDR versus HDR comparison. I mean, I think the goal is specifically to essentially expand the range of values so that HDR content can show that it is in fact more complex than SDR content, right? Because it can represent a wider range of values and presumably have more information. I think if for backwards compatibility reasons we wanted to also output the legacy SDR only range, I believe we can solve that in the final normalization step. Like if we look at the YPQ values, given that for certain display models they go only from 0 to 0.66 whatever, I think we can change the final scaling to put it closer to what we'd expect, where the maximum would map to 55 instead of multiplying by 0 to 55 and multiply by a different constant. And I suspect that will kind of do it. So if you wanted to say, if you're not concerned about HDR, you want to look at SDR only scores, you can use this value, but otherwise in the new HDR SITI, then SDR content is going to be lower scored on purpose.
Yeah, this is a perfect segue into what I was going to mention, because I was also going to address this. And since we haven't done the proper analysis of the HDR content yet, that's exactly why we were not really messing about with the mapping yet. But that the purpose is exactly as Shahid mentioned, to make it as backwards compatible as possible, whilst also capturing all these effects of different formats. So yeah, we have it in mind, but we want to wait for really having more rigorous test set and make sure that things are indeed backwards compatible, and also show all the effects that we want to show with the new SITI. So yeah, thanks for that, Cosmin. And yeah, thanks Werner again for a great presentation.
And I guess I'll make one more quick comment on the motion compensated part. I mean, I think one of the reasons we wanted to avoid using some specific encoders, specifically so we can use some values that can predict performance and then compare the performance of multiple different codecs. So we can, on content that's classified as whatever 0.8 on the compressibility scale, we see that VP9 LiVPX performs better or worse than we'd expect compared to this other encoder, etc. So I think having something that's decoupled from a specific one allows us to be able to make predictions across X264, HEVC, VP9, AV1, AV2, VVC, whatever. And of course, we'd expect some sort of differences from each generation, but still having something that we can plot all those onto, I feel like is a necessary thing. Otherwise we kind of pick one at random, and then it's not very clear why is that one the anchor.
Yeah, if I may respond to this comment actually. So my line of thinking is that I think 8.264, which by now I think we can pretty much say that it's a legacy thing that can be used as a reference to judge the quality of a certain, let's say, the encoding complexity of a certain video, and all those new developments, they can be of course compared, and they are actually anyway in the compression community are compared to the legacy, right? So it makes a lot of sense to actually compare the encoding complexity also to the same reference.
And that's a very good point. And actually, we're very much planning to benchmark against using exactly that, like using some specific X264 encoding as kind of the baseline, if you will. And the goal is to basically make the new metric cheaper to compute, and hopefully, just as, or close enough to the same level of prediction power. If at the end of the day we're no cheaper than X264 and the prediction is no better, then obviously there's not really a lot of reason for that. But the hope is that we can do it at a fraction of the cost and still maintain most of the same correlation.
Okay. Are there any other questions or discussion before we move to our next topic?
There's one thing, Margaret. I'm not sure if I will be able to take part in a second session on Friday afternoon. So I would find it. I would appreciate it if we could find a date for the next meeting. If we could take a few minutes to, because we haven't scheduled any calls for next year.
Okay, I would rather deal with that now than put it off. So we had agreed to have Sam on the 10th of January. I personally would prefer to stay with the same time of day we've been having these norm meetings, which is this on a Monday at the same time as the Sam, but a different week. So I would suggest either the week before or the week after the 10th. So that would be the 3rd or the 17th.
I have a preference for the 17th.
Okay. Are there any objections to the 17th to continue this discussion, which is the standard metadata? Okay. Sorry, the SITI. I was looking at the wrong thing. SITI discussion, and then maybe schedule the standard metadata for the week after, which would be the 24th.
That sounds good. It seems to keep to with our previous cadence, more or less. So,
could we? Hello, everyone. Could we move this to a slightly later hour of the day? I mean, for me, it's problematic. I really would like to start attending those again, but I have a lecture still to give at that time every Monday. Actually, that's why I'm actually not taking part in any of those meetings, which is not a bad thing because Werner and others are handling this very well for the SIT, but Sam, standard metadata, I would actually like to be participating.
Okay, so would you like them both to move an hour later or just the standard metadata?
No, it's fine. I think it's fine if just the standard metadata would be moved by actually ideally 90 minutes. So maybe starting at 6:30 or so, I could probably arrange a bit later.
So would that work for the other people who are online still?
I would have no objection to moving all of the meetings by that time. I think I can accommodate that. It's nice if they're all at about the same time, just because it's easier to keep track of, like, just to remember the date and not the time also.
Yeah, my calendar, Monday mornings I've kept open, so for me that works.
Okay, so I mean, if this would work, Tuesday would also be an option. Then I could actually do 5 o'clock. I mean, if that's a possibility. But you indicated that Monday would be preferred on your.
Yes, I've kept Monday mornings open, but Tuesday I am filled with meetings all morning. I just have no openings at all. And I've been hosting, so that.
I mean, things will also change in February for me because then lecturing is over again. So it's really just until, say, first week of February where I'm a bit limited. So maybe we can just exceptionally move the standard metadata by a little bit of time and then go back to Monday 5 o'clock for all the meetings, because then I can arrange that easily after February. I very much appreciate your comment.
Michelle, do you have a comment on that?
Yeah, I mean, a temporary change, I don't think it can be handled. But otherwise, the time I like 5 in Europe is like a sweet spot in the world time zones. I mean, it accommodates people in the US to participate in the morning, and there's still working time in Europe. And if someone in Asia would like to participate, there is, although probably very, very late, but still it's not like 2 or 3 in the morning. So I think that's why I guess that has been a popular time.
Okay, let's just do it like this. I will check with people from our surrounding our group, basically, whether they can participate in the standard metadata for that one, and then the next one will anyways be in February, and I think I can be participating then, right? I just felt that I lost a little bit track there, unfortunately, but I just try. It's not a big deal. Not just yet another meeting will be missed by me. I mean, I arrange with Rakesh and Werner and others, you know, in my vicinity to hopefully participate.
Okay, well, by all means, let us know if that doesn't work out. And we can have a discussion about moving from our usual time, which, as you said, is very inconvenient for you, to sometime you can make it. And just maybe we, I will note it as an item to discuss at that meeting in particular. Okay, any other issues before we move on? Okay, now just quickly before we close, are there any other issues or discussions on SI and TI that you would like to delve into this Friday when we have a little bit of extra time? No? Okay.
No, and I don't think it's a good idea since Werner's not going to be there. Yeah. I don't think it's necessary. So let's keep it for the meeting in January.
Okay, perfect. All right, then thank you very much. And our next presentation is 206. This is from myself and a few other people. So I sent out the question to the norm reflector and a couple of the other reflectors before putting this presentation together, asking what data sets we should be training no reference metrics on. And I'd like to go through this one fairly quickly. The goal is to have the information available in the presentation and add to the minutes any data sets people think we missed that should be used for this no reference metric training. So for each of the data sets, we collected the type of media, what is the use case, if this is designed for no reference metric research or not, where can you find a publication describing, where can you download it, and some brief information about the experiment design. So I'm going to start with the 12 data sets that I've been using and then move on to the data sets other people suggested. And I'll ask for the people who suggested these data sets to speak up at that point. So the first data set I've been using is the Blurred Image Database BID, and it's an image quality data set with user-generated content, a fairly inexact experiment designed. There was a private collection of photographs from a single DSLR, and the authors chose photographs from that collection. It means it has a very diverse set of subject matter, and it's all focusing on different types of camera blur. And that's the aspect that I think is interesting about it. The second one is CCRIQ, Consumer Content Resolution and Image Quality Data Set. That's one that I did with Phil Corvu at the time at Intel and the University of Ghent. And this is an image database of user-generated content where the same set of 23 cameras were used to photograph different scenes. So it's got a very rigorous structure with identical scene compositions, but some difference in how the cameras were held, distance, framing, and so on. And all of the images were rated on both a 4K and an HD monitor. So it splits out nicely by subject, by camera, and by monitor, helping the designers look into those factors. CCRI Q2 and VIME 1, this is a small set, splits into two pieces. CCRI Q2 is a few scene compositions that were photographed for but not included in CCRI Q2. VIME 1 are photographs taken by VQEG people at our meeting in Scotland. And these images were rated by Mikawai's students in a previous year. And then Jakob analyzed the data set and found some problems with the VIME 1 part, these cityscapes, where it's not as carefully balanced of a set of images. Nonetheless, as a whole, I think it has value to look at, as long as you're aware of this problem. The Camera Image Database 2013, another image quality database with user-generated content, a very rigorous structure with limited subject matter. It's mostly people and a lot of indoor shots, identically photographed with multiple cameras. The subjective method, I didn't add notes here, but it's not one of the standard methods. They they modified slightly. ITS4S2 is a selection of images, some collected by VQEG, some from other people on the internet. And it's all user-generated content, but some of it is depicting first responder situations. So it's about 60% UGC, 40% selected to demonstrate first responder tasks. It's an inexact experiment design focusing on specific characteristics of images or specific impairments. Like there's a large set of a lens distortion from fisheye lenses, as an example, and a lot of scenes of flat surfaces. So there's a very diverse set of camera capture impairments and scene characteristics. The Live Public Domain Subjective in the Wild Image Quality Challenge Database, I've been calling Live Wild because that's a really long name. This is an image data set with user-generated content. Like a lot of these data sets, it's a slightly inexact experiment design. It has a nice set of mobile phone device and camera capture impairments with very diverse subject matter. This is a 500 by 500 pixels, so it's not obvious, but presumably trimmed to that resolution after capture. ITS4S3, this is a video data set of first responder content. It's simulated first responder content created by videographers who were asked to show the type of impairments that first responders, who are amateur videographers, would capture in typical scenarios they encounter. So it's a somewhat exploratory experiment design, I would say, because of how the impairments were selected. They were selected by 6 different sets of videographers, and there were professional videographers recreating these situations and this use case. ITS4S4 is a video data set that focuses entirely on camera pans. It's a mixture of user-generated content and first responder content. It's a mixture of actual camera pans and simulated camera pans. And this was a proof of concept for the idea of creating a data set specifically to design a metric that tracks that exact impairment. And we heard the same approach used for the Cambry no reference metric earlier today. ConeVid1K are 8-second videos of user-generated content, a very rigorous structure to this experiment where they used an objective set of criteria to select these videos. It has a very diverse set of subject matter and camera capture impairments. It might be considered suboptimal for experiment design because there's definitely temporal changes in quality, and there's not a way to separate out those temporal changes in quality from the more immediate measurement of quality. And some of these impairments were filmed between 2004 and 2014. And so they depict lower quality than you see in contemporary cameras and services. Nonetheless, I think it still has a lot of value for this research. ITS-4S video of 4 seconds long, mimicking adaptive streaming use case. It's mostly entertainment, but has about 16% first responder content. This is a rigorous structure using an unrepeated scene experiment design. That is, there's a lot of similar content, but the same video is not seen twice, and the video is all from professional videographers. There is an occasional scene that has a low quality source, but they're rare, and the data set splits nicely by bit rate, so you can get some feeling to how the metric responds as bit rate drops. And there's 2 additional sets of ratings. Part of the data set was rated by AGH students, and part of the data set was used for the 4-itero method that we talked about during SAM yesterday. AGH NTI Dolby, these are 8-second videos, broadcast content. And this was an experiment designed to look at unrepeated scene experiment designs. So it's partially a rigorous structure with a conventional scene by HRC and partially unrepeated scene designs with a mixture of MPEG-2, H.264, and H.265. So diverse subject matter, and it was conducted by our 3 labs. Like the other data set, this one has temporal changes in quality. VQEG HD cuts I spoke about earlier. This is a faux experiment. I have some issues with it, but it does let us join together the VQEG scenes while looking partly into what is the impact of the different segments on quality. Maybe it would be better just to use those scenes without, but I haven't done that. And I believe, Nikolai, this is your database. Are you here? I'm not hearing from Nikolai, so I don't think he's attached right now. So
I can shortly present it. It's a footage from a CCTV camera covering a small part of the parking lot, and there are cars coming with natural lighting and natural weather conditions. So it's a good example of a traditional CCTV camera footage.
thank you. And SINAT. I don't remember who suggested the SINAT database. Oh, no, that was also Nikolai. Lucian, would you be willing to give a short summary of this one as well?
I'm afraid I cannot. Sorry for that. Just don't remember this database.
Okay, well, Nikolai suggested this one as a video database, 10-second videos for broadcast and internet streaming. And I'm afraid the information here is what we have available. He says there's some full reference and no reference metrics that have already been created, and it's JMX264 encoded video sequences. I've not looked at this database, and it would certainly be interesting to try other no reference metrics on it. The sharpened image database. Is somebody connected who can give us a summary of this database?
Yeah, that would be me. Thanks, So this is sort of a niche database that was developed during my time at the University of Nantes. And the idea here is to have blurred, sharpened, and over-sharpened images in one database, let people evaluate it, and then test the ability of objective metrics to find this, let's say, peak quality. So something that we all know that when enhancement is involved, we are able to introduce like improvement in terms of quality, but then it really quickly goes down when we over sharpen it or over enhance in general. So this is capturing that. It only has 4 source images, but it has a lot of different sharpening methods and different parameter settings for these methods in order to really be able to capture the different ways photographers would enhance the images. The only problem for metrics training is that it uses per comparison. So we introduced with that also a way how to use this database for objective metrics training, but it's not as straightforward as a regular one. So that's probably the only caveat I would see there.
Okay, thank you. Yeah, that should be a nice complement to the BID data set, which I've been thinking it'd be nice to have more sharpened blur.
Yes, definitely.
Okay, the tone mapped image quality database TMIQD.
Yeah,
Lucas,
that's again me. And yeah, this one's also developed by University of Nantes. This is more about tone mapping of high dynamic range images for SDR displays. And this is actually a rather large one. It has 20 different sources, 10 of them natural, 10 of them synthetic, and 9 different tone or HRCs. So there are 4 different tone mapping operators with 2 different parameter settings and 1 extra with no parameter settings. So a lot of ways to tone map different images, and then they are compared with per comparison fashion again in order to like both preference of the images and also of fidelity to the original. So especially the preference part would be really interesting for no reference metrics because it takes a lot of aesthetics into account as well as naturalness and so on. So interesting from the perspective of this overall or heuristic metrics. All the resolutions are 1080p, and yeah, there are some specific artifacts introduced by the tone mapping, so quite different from the standard things that we're used to looking into.
Thank you. This is another one I look forward to looking at. The Youku V1K data set we heard about earlier today. Jingli, are you still here? Is there anything else you'd like to say about this database?
Yeah, I'm here. And this video database contains 1072 video sequences, and the duration are 10 seconds for each one. And now I think the special part for this database is we contain the UGC, PGC, and OGC content here. And yeah, we have very well designed for the subjective experiment and also for the selection of the database, as I explained earlier, for the sampling strategy. And we try to make this database as universal as possible for the training of the no reference metrics.
Thank you. Okay, our next one is gaming video set. And is there someone on who could talk to this database?
Yeah, hi, Margaret. This is Navjit. Sorry, just give me 1 sec.
Sure.
Yeah, I was hearing an echo, so I was just checking the settings. So yeah, this is the gaming video data set which we published in 2018 as part of Kingston and Technical University of Berlin. So It consists of 24 games, 24 videos from 12 games. They are of all 30 seconds duration, and we do consider different resolution bitrate pair. So the native resolution is 1080p, so full HD and 30 frames per second. But the subjective data set that we have consists of 3 different resolutions and bit rates. So they are in total 6 videos and 1080p, 720p, and 480p resolutions and different bit rates per resolution. And the methodology used is ACR, and the data set is publicly available for download, but yeah, you do need to request for the password to extract the files. So the instructions are all available in the dataset link. And we do have the individual subjective scores also for this dataset.
Nice, thank you. The next data set, Navjeet, for you as well.
Yeah, so that's the Kingston University gaming dataset, which again it's actually designed similar to the gaming video dataset that we saw previously. So here we have 6 videos, which are again so one of the game is actually same as the previous from the previous dataset, and if you want to compare subjective test results from different labs, one can do that. We also have here individual subjective scores. I forgot to mention, so for the both dataset, we do have already 3 full reference metrics, PSNR, SSM, and VMAF. 2 reduced reference metrics, speed QA and STR rate opt, and 3 no reference metrics, so NIQE, BRISC, and BIQI values available as part of the dataset. Yeah, again, you need to request for the password, but the videos and everything can be downloaded from the link provided here.
Thank you. And here's your third.
That's me again. So the gaming HDR video set, it currently consists, it does not consist of any subjective scores, but we are currently running some subjective tests. So hopefully by early next year, we should have it ready and published and available to everyone to use. So these are actually 4K gaming videos of HDR, 10-bit HDR quality of BT 2020 non-constant luminance perceptual quantizer. So that these details are provided in the paper. It can be considered somehow to be user-generated content because there is a maximum limit on how you can actually capture gaming videos of say up to only 200 Mbps. So they are not say very pristine quality, but they are actually of very good quality. And the paper actually performs a codec comparison analysis. So the subjective data set will consist of subjective results for 4 different codecs: X264, HEVC, VP9, and AV1. So that's something we are currently doing, and hopefully it will be published soon.
Thank you. So if you have any other databases that you recommend we use for no reference metric training research, please enter those dataset suggestions into the meeting minutes. I would be interested in hearing about them, and I'm sure the other people working on this problem would as well. So that's basically our point here, is to try to get a larger set of data sets to train these metrics on, especially given the results I was displaying earlier, where I'm suspicious of the reported accuracy and training accuracy of these metrics based on being overtrained with too little data. In particular, there's a lot of interest in broadcast applications expressed at VQEG and fewer data sets that really do a good job demonstrating this use case compared to the level of interest. So that's an area where I would particularly like to see some other suggestions. And it's wonderful to see the specific use case data sets that were just suggested. So I'd like to open it to just quick conversations. We have 2 other topics. I'd like to at least fit one of them in today. But are there any other questions or suggestions before we move to the next presentation?
Just if you need, you can fit in the presentation on Thursday. So for the CGI group, we don't have many presentations for that time slot. So if you want to reschedule, that should work.
Okay, that would be helpful. We have 233 and 235 remaining. And 233, Shahid, that's yours. And 235, Franz. And we are scheduled to end, what, in about 20 minutes? And I'm not sure either one of those we could fully get through.
So if I can jump in real quick, I'm a bit under the weather anyway. So if we postpone my talk to Friday, that's absolutely fine by me, or Thursday, that's absolutely fine by me.
Wonderful. Franz, I will put you on Friday, 235. And Shahid, you had predicted 25 minutes. That would put us not too much after our expected ending. Is that okay with you?
That's fine with me. And if you think that it's better to move it all together, then it's also okay.
No, I would rather do it now as long as everyone is okay with going a little bit over.
Mm-hmm.
Okay. Any questions before we move to Shahid's presentation? Okay, Shahid, it's all yours.
Thank you. So let me share my screen. Do you see my screen?
Yes, there's what appears to be, oh, now it went away.
Okay. Okay.
Yes, but there's two gray boxes covering part of your screen. Now there's just one, a small one in the middle bottom.
Is it okay now?
There's two areas where there's a gray box overlapping. If you have other windows open on your screen, that might be what's happening.
Just a minute. Is it okay now?
Right now, I can't see your screen.
Mm-hmm. Now?
Again, there's that gray box in the lower right.
There are now actually 3 boxes. It looks as if you were actually. No, one is gone.
Okay. I understand it.
But still, there are
there's
still two boxes. Yeah, it's still the case. As if some windows were open that are overlapping with yours.
I think the boxes are the taskbar for Teams at the top, the sharing taskbar, and the volume, and also there was this preview you have of the video to the lower right. I think it's actually inside Teams more or less.
Then now is it okay?
Well,
there are some black rows in the top of bottom. I think it's useful anyways.
Yeah, I mean, let's try it out. I mean, if you don't have content there, then I think it should be okay, right? I mean, it looks as if there was some content being censored, sort of, right? I mean, unintentional.
Actually, don't. Margaret, I sent you this presentation. So if it's too much disturbing, then maybe you can share it and I can.
Hold on, I haven't gotten to. Hold it. Did I already post it to?
So I sent you by email in response to your email.
Okay, hold on. I haven't had a chance to go through. Okay, let me download and share, and people can tell me if it. 2, 3, 3.
Now the top black bar disappeared for you, Shahid.
It's getting better.
It's just the one in the
It's just a small one which is left.
And where it is
Towards-
actually in the bottom right.
It's in
That's
the middle
gone.
down. It's like like in Zoom and things like that. You have some menu buttons in where you can mute and stuff. It seems to be around that place.
Hold on, I'm opening up.
It's basically in
your
the middle to the
slides.
left of the PVQ logo.
There is no chat in this Teams meeting. Otherwise, I could send a screenshot. Or is there a chat?
Sorry, hold on just a minute. It's downloading from my network drive onto my local computer so I can display it.
Just sharing my screen for a few seconds so you can see whatever was on your screen. I don't know if you can see it. You see the black fields here.
Yeah. Okay, I've managed to open it up and I'm going to share. Okay, how does that look?
Much better.
Okay. All right, Shahid, just tell me when you want to change slides.
I am back. Actually, while trying to fix, I just killed it completely. Can you hear me?
Yes, we can hear you.
Okay, perfect. Finally. Okay. Sorry for this inconvenience. So the topic of my presentation is the encoding complexity of short videos, something along the lines of what we were discussing in the presentation when Werner was presenting, and I think a similar presentation was presented in the morning session by Vignesh. Can you, Margaret, go to the next slide? Okay, so we know that the encoding complexity and video quality has a very important relationship. Like if you have everything constant, bitrate, frame rate, resolution, etc., and you are encoding a video using a certain encoder, the video with the higher encoding complexity will get lower video quality. The video which is easy to compress has a small encoding complexity will get the higher video quality. One click, Margaret, one click can you do? Okay, so but here in this presentation, I'm trying to explore this reverse relationship, like what can we do with the video quality to actually measure the encoding complexity. Essentially, you can do some probe encodings, and you can measure the video quality using a full reference method to actually characterize the encoding complexity of a certain video. I'm talking about the encoding complexity and not about the scene complexity. These two can be different things, and I'll try to explain it in the coming slides. Next slide. Okay, so what is actually the encoding complexity? Is it the scene complexity as it is normally characterized by SI and TI measures? Can it be a universal quantity? That is, can it have a universal? Can it be a universal measure that we can say that let's say the encoding complexity challenge that one video is posing to a certain video codec, is it the same that it poses to the any other video codec? what is the effect of technical parameters like resolution, bit depth, frame rate, etc.? Can we say that HDR video, as Cosmin was saying, that it actually has a higher complexity compared to an SDR video? So to our understanding, scene complexity as it is characterized by SI and TI, it's a slightly different thing than the encoding complexity. Imagine the case that if there is a still video where the spatial complexity is high, let's say there is too much detail in that one frame that is repeated over and over, SI will say it's a high SI value, but the video codec can easily compress that. It doesn't have to encode the second, the third frame, and every repeating frame again and again. It can do very easily. So a certain scene complexity in the spatial sense may not mean very high encoding complexity. Also, if you have a translational motion, video codec can easily compress that using linear motion compensation. So a TI indicator may not be actually telling how much complex a video is temporarily. So this discussion is along the lines of what we were discussing when in the last presentation, where we were saying, okay, can't we use the video codec itself as some kind of tool to measure the encoding complexity? Can you go to the next slide, Margaret, please? Okay. So how I define this encoding complexity, and this is a very loose definition, I think, but this is the definition I work with, is that the amount of challenge a certain video sequence puts to a video codec can be defined as the encoding complexity of that video, and it can be computed using by doing a rate distortion. The characterization of the rate distortion curve of that video, essentially compressing it with a range of bit rates and measuring the video quality using a full reference measure, as I'm going to do it in the next slide, please. Okay, here we see that the rate distortion curve of two videos. The red one is let's say a more complex sequence. Some motion is involved. There are people running for a marathon in that. So it's a higher complexity video compared to this blue one, which is essentially a car driven on a road, I think. So you see that on the y-axis is the VMAP score, and on the x-axis is the log bitrate, encoded bitrate. And you see that for the blue curve, the quality is maintained at a say larger range as we go down the bitrate, reduce the bitrate, and for the higher complexity sequence, the video quality drops very quickly as we reduce the bitrate. Can you go to the next slide, please? Okay, so essentially we can define some kind of a video quality based encoding complexity measure using the area under the curve. So for the blue curve, we can say that it spans a higher area. So higher area, lower complexity, and for the similarly for the red curve, or we can actually take the complement of the area, that is this area above the curve, just to have a same relationship with the encoding complexity. So if you have a smaller area above the curve, you have a simple the encoding complexity is small, and if the area above the curve is big, then is higher encoding complexity. Here R star is some value, which is a fairly high value at which you are sure that any video sequence will actually reach, the video quality will reach a saturation point. That is, you cannot really improve the video quality. So what I found is that for UHD natural content, 100 megabits per second is fairly a high value, and normally you can actually reach that saturation point. So here this encoded complexity is essentially this area divided by 5. This 5 is just to bring it more or less in the same range of values as the MOS values. Yeah, so actually in the coming slides I did not use this normalization by 5, so you will see the value more in the range of let's say 1 to 25 or some. Okay, you can go to the next slide then. Okay, so now we have defined this notion of video quality based encoding complexity, but you see that you have to do let's say at least 4 or 5 probe encodings to measure this area over the and you have to do the full reference computation. So this is actually expensive, right? So how to cut down on this computation expense? So here I have presented a very simple algorithm. This actually involves some kind of limitations that I will talk about later, but the idea is just to present a simple formulation that was actually found to be working in the context of measuring the encoding complexity. So what I did here is that I took that video sequence. The video sequence I'm talking about are normally of the length of, let's say, 8 to 10 seconds. Let's say they're comparable to the typical segment length that we see in the VOD transmission. And so I took that video sequence and I compressed it using the CRF encoding of X264 codec. H264 and X264 is the implementation of H264. And what I did is that this resulting size of the file, I normalized it with the resolution. This W is the width of the frame, H is the height of the frame, frames per second, and T is actually the duration of this video. And I computed some kind of a bit per pixel measure, and the encoding complexity is computed simply by taking the logarithm and scaling it with this factor A. So this is a very simple algorithm to actually approximate this video quality based encoding complexity measure that I introduced earlier. Now the question is what CRF value to use. So the idea here in this algorithm is actually you let the CRF algorithm basically track the complexity of each frame. It will introduce it will allocate higher bits to frames which are complex and lower bits to frames which are less complex. And overall, the resulting bit rate will be some kind of a indicator of the complexity of the video. Next slide, Margaret, please. Okay, so I now go into the experimental evaluation slide. So we did the experimental evaluation using around 730 video sequences. These are UHD sources, and the middle graph shows the SI and TI. So you can see that these sequences span a fairly large range of SI and TI values. On the left side, I have plotted the VMAP scores with respect to the log bit rate, and on the right side, our in-house PVQ, which is also a full reference measure that was computed for these 730 sequences, and it's plotted. What I wanted to show here was actually that the RD curves are spanning a big wide range here. So because these 730 video sequences, they are coming from very different type of sources. There is sports content, there are natural videos, and even some game related data. One small thing I want to point out here is that the VMAF score, they go from all the way from 1 to 5, while PBQ scores, they stay in the range of 1.5 to 4.5, more or less 4.6. You can say there's, in my opinion, there's no right or wrong here. It's only that PBQ is more tuned to what we get from the subjective scores, and from the subjective data, you hardly see the scores are going all the way up 5. Rather, they stay between 4.5 and 1.5, because there are always some people saying that the video is not perfectly good or perfectly bad. Let's see. Next slide. Okay, so in this slide, I have tried to compute this ground truth video quality based encoding complexity for VMAF and for PBQ, this area above the curve for both measures. And you see that they are fairly in agreement. The Pearson correlation is around 0.87. It's a fairly high value. Mind you, it's not a prediction of quality, so the correlation coefficient may have a slightly different kind of a value range here, but I see a very good trend, so they're kind of in agreement. Next slide. Okay, so here I have used the SI and TI to actually use an average of SI and TI to come to an estimate of the encoding complexity. Again, you see 2 curves, one for VMAF and one for PBQ. And you see that the value range is around 0.4 and within 0.4 to 0.5. I could have used more complex way of combining SI and TI to make this prediction. But overall, you see that there is a big, how to say, the cloud is quite thick. So, to my understanding, these SI and TI values in this formation or this linear combination are not really the best way to actually measure this encoding complexity. Next slide. Okay, and in this slide, I have tried to compute the CRF-based complexity calculation method. It's approximation method where I use the CRF encoding, and the resulting bitrate I use to compute the encoding complexity. And I have computed the correlation, Pearson and the Spearman correlation for different CRF values, and you see that there is a certain value on which this correlation is fairly high, and as you move away from this value, so these correlation get low. So there is an kind of an optimum CRF value that you can use to measure the encoding complexity using the CRF method, and this value is CRF of 35. Next slide. Okay, so here I have used this CRF of 35, and I have plotted the computed encoding complexity with respect to the ground truth. I think this result is coming from the VMAF, and you see that kind of a very nice relationship it has with respect to the this encoding complexity ground truth. The cloud is you can say that it's still thick, and that is there is a reason for that. 2 clicks or maybe 1 click more, Margaret. And you see that actually these are not 1 but 2 clouds, and The reason there was that the videos, they were 60 FPS videos also and 30 FPS videos also. So you need some kind of additional normalization factor to bring this two clouds into one. And the reason is that 60 FPS videos, they do not take double the bit rate to actually come to the how to explain that? So 60 FPS videos do not to compress for the same quality. 60 FPS videos does not need to be compressed at twice the bitrate, because you have frames in between the frames, and you can actually use some kind of a normalization factor to make this encoding complexity measure slightly better. So this is something I'm still working on, and I have a fix for that. And if you do that, then you can make the correlation go a bit higher even. Yeah. Next slide. Okay, so till now I have been in the previous slides I was presenting only the uncompressed video sequence, where I was taking these uncompressed video sequence and then compressing it with the CRF. But here I have tried to present some result where already compressed video sequences are used. This is this can happen when you already get a compressed video. For example, if you are streaming the video and you want to measure the quality on the client side, you will already get a compressed video. So how, if you can use the compressed video to compute the encoding complexity? So here different rows show how that video was compressed. So the top row is actually the okay, so one clarification: the first table is are the scores for the VMAF, and the bottom table is the scores for the PVQ. So the first row is UHD content original FPS. So this is the case where it is uncompressed. The second row is when you downsample along X and Y domain by 2, so you get to HD quality and you still use the original FPS, original frame rate. And the third one is that you further downsample it by 2 and use the original FPS, original frame rate. And the fourth one is when you use quarter of UHD, that is I think 720p and 1/4 of the frame rate. And you see that this Pearson correlation and Spearman correlation, they gradually go down. So it means that with this compression artifacts, the prediction of your encoded complexity deteriorates. Next slide. Okay, so here I have tried to sum it up by giving an example of an application in which this encoding complexity measure can be used. And one application is you can use it for a hybrid node reference, for building a hybrid node reference metric. And ITU P1204.5, which was recently standardized, is actually using this encoding complexity measure. In particular, this method is using 4 features, 5 features actually. So now there are 4 parametric features: codec, bitrate, frame rate, and resolution. And one feature is this encoding complexity. And on the right side, you see that the scatter plot of the subjective quality with respect to the prediction made by this hybrid node reference measure. And you see that it gives very impressive performance. There actually I have used CRF of 23, and I have used VP9 encoder. CRF of 23 was found to be the best working value for VP9 encoder. So this is just to highlight that this method also works if you use some other codec. And there is an update plan for P1204.5 to extend it to AV1 codec. Originally, it was proposed for 80264, 80265, and VP9. This is more or less it. If you have any question regarding the encoding complexity measure or regarding P1204.5, the floor is open. You can ask.
So do we have any questions? Lucian?
Well, I'm not sure if this is a question. I just want to appreciate a very interesting analysis. And in my opinion, yeah, this is a very good idea to also like validate it, maybe even more, because especially for, like you said about the use cases, in my opinion, this is a nice idea to use it for the subjective tests where we really need, where we have time. Yeah, we can really use this analysis. There's no problem, and have a very precise understanding of what kind of coding complexity sequences we're using. Thank you very much.
Thank you. Shahid, I agree with Lucian. This looks like a very useful approach and simple enough to be practical in real use.
Yeah, especially. Yeah, please go ahead.
No, go ahead, Shahid.
Yeah, so we have tested it actually to see to see what speeds we can achieve, and actually you can have because it's essentially it's one encoding that you need to do, and you can do it in close to real time also. So unlike other measures of encoding complexity, I think this is a fairly fast way of approximating it.
Yes, thank you. Alex?
Yes, thank you for the presentation. Just for my clarification, this is not very different from what was used already in PNUTS phase 2 for content complexity estimation during the subjective test, is it? Or did I miss something? I mean, yes, I agree there were further analyses now, but in principle, it's the same idea. Or is there, did I miss something substantially new there?
So we took the more or less it is the same. Yes, you're right. More or less it is the same. The thing it differentiates in P1204.5 is that it's working with already compressed sequences. But in but in PNUTS 2, we use this measure for creating these complexity classes of the SRCs.
Yeah, I was just wanting to point that out because it's linking to Lucian's comment. I mean, so we essentially already did use it, right, in a way. And I may also want to point to a QMX paper from last year that Werner Robertson mainly authored about some related analyses, also considering, again, SITI, right? It's a short paper at QMX. It's actually this year, 2021. I can send the reference as well if you're interested. Thank you.
Yeah.
Any other questions or comments? Okay. Hearing none, thank you, Shahid, for this interesting presentation. And that's our last presentation and discussion for the day. I didn't, because I was presenting slides, I couldn't add much to the meeting minutes on this. My apologies for that. But I'd like to approve the minutes before we close for the day. And hold on while I share my screen. Okay. So the whole day was on norm. We started with 205 from Lucas on the CAMBI method. And I inserted the link to the GitHub repository. And Lucas inserted a reference to the blog where we can find more information. 207, is there a comment here? I guess not. User-generated content in the wild by Mikawai. Um, 209, video complexity analysis for streaming applications by Vignesh and Hadi. And we note that the code, they hope to release code by March of 2022. Next was 210, perceptual quality assessment of internet videos by Jing Li, where the Youku V1K database is available, and the objective metric SDAM was described, which is currently for internal use. Presentation 202, why intermetrics fail, by me. And some comments from the discussion afterwards. Presentation 212, UVQ, a new no reference metric for UGC by Balu and Yilin. And the videos and subjective scores are available, and they also hope to make their metric available open source in 2022. (203), our discussion of standard video quality metadata. Yanis led the discussion, and I'd like to note that Facebook, the company name has been changed to Meta. And there's the link for the VQEG being an official T35 terminal provider. And we will continue that discussion. Let me highlight that. On December 17th. That should be a Monday. Oh no, that's this week, sorry. Okay, and then 204, updating SI and TI. Lucas, Kosman, and Werner. There's two links there to GitHub repositories, the main branch and the under development branch. We have minutes and a link to the Python code, and we've agreed to have our next two audio calls on the 17th and 24th of January. (206), the Data sets for no reference metric research. And see the presentation for details. And thank you to whoever entered this data set, AVT VQDB UHD1.
That's the database from Dielmanau in Germany. So,
thank you.
Yeah.
Much appreciated. And let's change those to be links. And then Shahid, would you like to note anything in the minutes on your presentation? Because I was presenting your slides, I normally was adding a short summary and I just couldn't.
Yes, I can do that. I can do that.
Okay, let's approve the rest of the minutes and let Shahid add some brief summary there afterwards. Are there any other changes people would like to see before we close today's meeting?
Yeah, I just wanted to say that for the no reference databases, I also think Jing proposed the database, so maybe she can be also listed among the authors there.
Ah, yes. Jingli, yes. Okay, any other changes? Okay, then we call this approved and we will close and reconvene tomorrow. Thank you very much.
Thank you.
Thank you.
Thank you.
Bye.